I work at NSSPH as a DevOps engineer. So today I'll be talking about Linux container hardening. So this is important because my fellow colleague from Checkmarks had just highlighted that we need to also secure infrastructure apart from just code. So just going like straight into a deep dive. I know some of us here are not used to using Linux, so I'll just try and break some of the things that I'll be speaking about here. Some of these things are just big grammars, really. They do simple things. So first is Linux. So what is Linux? Sorry. So Linux is just, okay, strictly speaking, Linux itself is a kernel. And but let's just generalize and say Linux is the kernel and everything that the kernel needs to run your application or needs to make a complete OS. And so what is a kernel? Check. So the kernel is just a tool that manages the hardware resources for a particular host. Then we move on to Linux containers. So Linux containers are what bundles all your apps. But is it JVM you have to need to run? It will be on the Linux container. Is it any other thing that the app needs itself? Is be on the Linux container. So there's something we need to establish now. The difference between a Linux container and a traditional VM. How many of us have worked with VMware or VirtualBox? Almost everybody here. Okay, yeah. So VMware is an hypervisor, and hypervisor is just big English. What it does is just manages resources, makes you install multiple OSs on one OS. So OS on top of OS. Now, a Linux container, what a Linux container is, or a Linux container, yeah, a Linux container. So there are different types. You have Docker, we have LXC, OpenVZ. How many of us have used Docker or OpenLXC or OpenVZ? Yeah? A lot. Okay, cool. So sorry. So the Linux container runs on a shared kernel, such that on that particular host, multiple containers can use the same kernel, and so it works and it works well, but it works such that the performance impact of running multiple OSs on a particular host is limited, is very low. But there are some drawbacks from that. How many of us have noticed latency issues with VMware if you are using a PC or VirtualBox, tech latency especially, input latency? Yeah, cool. Sorry. Yeah, so I'm just speaking about template containers. Then, so we've used Docker, Docker Swarm, Kubernetes, Mesos. Your hands, please. Thanks. Cool. So this is important in that. So when a Docker container image has been hacked or it's now vulnerable, and so there was an issue recently this year around February or March that it was a RunC vulnerability in which the root from the Docker container was broken into the root of the host. So I'll explain how you can mitigate that later on. But so when that happens, so the way Docker container orchestration tools work is that they help you distribute several copies of your app or your containers across multiple nodes in the cluster. So a cluster is just like a collection of servers that run your application. So when your application gets hacked, it makes container orchestration tools make it easy such that your container your cluster can easily become hacked because they will always distribute your apps like all over the cluster, and so it makes it easy to distribute the hacks and everything onto. Sorry. So what's container hardening? Container hardening is just a way of saying, okay, I have an application. I don't want the application to do more than it says it does. It says it does. I don't want the application to be able to go onto my host and start destroying everything there. I don't want the application to be able to go to the host and start tampering with network resources, CPU resources, such that a denial of service attack happens or a box get overloaded and all those things. So why do we do this? Why do we need to harden our containers? So we need to control the kernel surface area. So how many of us knows that the Linux kernel itself, like they discover vulnerabilities almost every day? Okay, well, it's cool. So vulnerabilities have been discovered every day, even from Linux kernel itself, and they're being patched and all that. And So a way of mitigating that is by limiting what the app can do on that kernel. Since on a particular host, multiple apps use a kernel. So if you can limit the resources that a app can use on the host, then you can limit its way of propagating issues to other apps on that same node. So just before we move on, I'd just like to clarify that I'll be speaking mostly on the Docker containers here, although the principles apply to almost every container tool that you'll be using. So this is the basic structure of how a Docker container is. There's the kernel at the base, then the C group, and then namespace. Please ignore the device mapper there, it's deprecated. So then there's the bootfs, then the layers upon layer of it. So the way it is structured enables us to be able to take security features of Linux itself, to be able to take advantage of it. Those are some of the features. User namespaces, kernel namespaces, control groups, also known as C groups. The Linux capabilities, SecComp, the security modules, SecComp, Linux, Hapamo. So for those of us that have used Docker, I'm very sure when we want to install Docker, the first thing we do is set Linux permissive, forget about it. It doesn't hang there. So I'll talk about what namespace is. So for those of us that use Kubernetes here, we've heard of namespaces, we use it daily. So namespaces are just a way of separating whatever resources or whatever processes your app is running on that app itself, such that that app cannot access the resources or processes on the other container on that particular host. Yeah. So such resources can include the network stack. There's C groups now. C groups means control groups. It helps you limit the resources, CPU now, memory that a Docker container can use on a host. Then Linux capabilities, they ensure that we can break down permissions. You know, typically we often do things with start the process with root and it ends there and anything can go haywire from there. So what we should do is have such a way such that at least at first a child process from a root process cannot have more capabilities than the process that started it. That's one. Then we should have a way of separating such that, okay, this is what this process is doing. It should not have more permissions than that process needs to do what it needs to do. Then SecComp is Linux security module. So SecComp started as a Linux security module that allows only for syscalls, Linux syscalls. So what a Linux syscalls is just a kernel function that allows you to control whatever resources on the kernel itself. So it started with 4 syscalls, but now they made the kernel SecComp BPF module from it. That's the one that we're really interested in, really. But they generalize it as SecComp really. So what that happens is that you can now whitelist whatever syscalls you have needs to make, and such that okay, in Linux we have about 300 syscalls. By default, the Linux container runs with around 256 syscalls. And really, if you look at it, we don't need that much syscalls. At most, a hello world have a web service needs around 120 syscalls, and that's the end of it. So coming back to the RunC vulnerability. So when that happens, now vulnerabilities get spread across your cluster, everything is bad, everything is running up and down, you shouldn't have to do all that. So these are the steps for you to harden your container reasonably. You can't do it totally. So these are the steps you need to take to harden your container reasonably, and I'll be going through them one by one. So many of us here, I myself personally, I've had cases that I've had to say go from PHP, MySQL, JS, Unicorn, image or container image really that has an all is like how would I put this down? It's like an all-knowing image. It does everything from the box. It may not be a good practice. So at least Even if you cannot start from Ubuntu itself or Alpine or any other thing and then have the packages, at least use an image that is committed that everyone knows in the community. You can use OpenJDK 12 or something, that is standard, not just one individual builds the image and you go and use it. That's a very bad practice. Don't do that, please. Then after that, we remove the executables that we don't need. There are a lot of things that, for example, widgets, you don't need it in a container image. Code, you don't need it. Some also other things. All you should just have is what starts your app, really, and that's it. All your app needs. So that's an example of the bash script that removes everything except what the app needs. Next step is to update packages. So there's a reason updates are made. Updates are made for a reason. We shouldn't just ignore them and move on with our lives. So you should update your packages normally as you normally do. Then next is download to a less privileged user. So how many of us have? Let me ask a question. So there's always been the case of you start a Docker build file and you add everything, and then you leave it like that. It runs as root, and so one day somebody has a execution access to that box, and so ordinary human mind will break root. From that stage, you can just go haywire. You should try and avoid that. Then the fifth is a user namespace remap. So what this means is just that root on that container image does not mean root on the host. It means that you are assigning that root to something else. It can be as long as it's not beyond between 0 and 99. You are 0 and 99 on the host. Fine. So that's an image, an illustration of this. So you don't need to bother yourself about this. I'll share links with slides later. The sixth is second profiles. So to generate your second profiles, you need two tools at least. Although it's one you can pick anyone you prefer. You can use either sysdig or systrace. So what systrace does is it debugs the syscalls your app is making and whatever states change that your app is making in real time. You see those calls and everything, and then you can process those calls into a profile, a second profile. Yeah, so that's the example too. You can use convert to a second profile. It's called syscall to second. So that's an example of how you run a Docker image using a second profile. Then the next part is if your app does not need to access the file system for a write operation, then just leave it like that. Don't let your file system be read write unnecessarily. Because it might lead to cases that, for example, PHP, and some of us that use frameworks like Symfony, Laravel, and the rest of it, in many cases that if somebody is able to, maybe due to one vulnerability or the other, the person is able to write another script into your file system and start executing, and you just start getting what you don't intend for them to get in the first place. The next part is the no root privileges. So what this means is that apart from now we've spoken about the user for the app itself. Yeah, non-privileged user. So what this means is that now that your app has its own non-privileged user, really you don't need root anymore. You can just run the container without using root. So there's a flag for Docker that you can use. It's called no privileges. Docker image will run without a root user. And the second to last is AppArmor profiles. AppArmor profiles they control access to the file system on the Docker container itself. File system, network resources, app itself. Last is Docker bench security. So what this is important is running the benchmark against the container image that the container host, such that is this container host optimized for production? Should some of these security concerns be left like that? So that's an example of the scan. What the scan looks like. So I intended to do a demo session. I don't even know if I have enough time to do that. Can you click? So for this demo, I set up a simple Flask hello world program and exposed one simple endpoint to simulate an endpoint that is vulnerable. can see it. For some of us that don't use Linux here, I'll try and explain as we move on. So the image has the app has two versions. One is the app with the container secured. The other is the app with it less by default, as you normally run without having anything. So that's the Docker bench security scripts. All it does there is just the Docker run command for the Docker bench image. And that's the S3 profile for the app. And then the second profile for the app. So those are the list of syscalls the app needs. So you see changes in the app itself in real time. The syscalls is making and whatever is passing to the syscalls as well. That's the Docker file for the app. So what this Docker file does is it installs pip, whatever it does, then hardens the image. It runs the shell script. What the shell script just does is removes some users that you don't need. Emotes the file system. So now I'm running the Docker bench scan against the container host itself. So there in there you see some red, some things listed in red. So those are field checks. So I won't spawn to, I mean not spawn because of time, to show the part that has to do with the vulnerable app itself. So time. So now I'm about to run the Docker run command with the second profile activated for the container. That's it to flags there, those new privileges and the second profile. So the app is running now, and I'm about to test for an endpoint exposed. So in this demo, the only kernel security mode that he used is second for time reasons. But on your own, you can make research on how to use App Docker supports it, Kubernetes supports it, every other container extension to likely support it. That's the endpoints that are exposed. It just exposes the bash shell. So the links to the repos are included in the presentation as well. So that's a simple ls command, but it won't execute because the syscalling needs to run another process for it, but it doesn't have it. You just say operational parameter and it generates 500. Catso as well, and you had anything really. So that's it really, if you have any questions.
Yeah, please, another round of applause for.
You have a lot of services you include and they are running on production, you understand. So is there, I don't know if it's your experience, is there a way to, and you want, the reason why I'm saying a lot of services is that you can't just start again and is there a way you can implement hardening to your content?
Yeah, so you can do that. And so this is in this demo, there are additional steps you can take to go further down the video, but because of time, so I'll share that with you later. But so you can automate the process of generating the second profile. You can, for example, run systrace or sysdig and run a regression, perhaps regression test against it. You get the profile generated. You can automate all that, and it works fine.
Thank you very much. Hello everybody. Thank you. Hello everybody. Oh no. Hello everybody. Okay, first of all, the food is coming. We look so tired and hungry, so yeah.
The thing is, talking about security, first of all, whatever framework you are going to use, they have their trade-offs when it comes to security. Let's say Python, for example, when you are considering Django and Flask. Django is more secure than Flask, but Django is not all that secure. So when it comes to cloud, first of all, they have firewalls. You have to put some firewall rules in place. Then they have what we call Cloud Shield. Cloud Shield will actually help you detect security vulnerabilities before they come into your your network. And then firewall rules. And these things won't solve all the problems. They will only help you minimize it. Then after that, they have third tier. Most of all these cloud, providers, they have third tiers. Like, I don't know what Checkmark does, like Checkmark. Google Cloud Platform have a lot of third tier security providers that help them to secure when the service level agreement that they have is they protect your your app, your product to a point in time. But if your app is very big and you need more security, you contact the the authority and they provide security. And one guy made mention of Azure. The guy said Azure, like when all the servers are down. Okay. When all the servers are down, all the servers cannot be down. If all the servers are down, they are disaster recoveries. They are disaster recoveries that you put in place. They are almost free, but because of recovering your data, that's what is expensive. We have nearline, we have code line. When you access your data once a year or maybe once a month. So that's it. Thank you.